Hi, everyone. Can you all see the whiteboard?
Yes.
Yes.
Okay. What answers did you get for the first question? Okay, good. A lot of people got Monday. Good. Monday is the correct answer. Let's see. Ishan or Anish, can you explain?
So it says that she finished her first book on Monday, which means she had to start reading it on Sunday. So then I just I wrote 1 through 15, and then I added all of them up using the Gauss method, and then I got 120. So if you divide 120 by 7, because there's 7 days in a week, you get 17 remaining 1, and then one day after Sunday is Monday.
Good. Yep. So you can add up 1, 2 up to 15. So yeah, one thing that Ishan mentioned was the Gauss method. So that is something like you can write the same numbers in reverse. So 1, 2 up to 15, you can write this as 15 plus 14 plus so on up to 1. And then you can imagine adding each of the things that are under or each pair here. So 1 plus 15 is 16. The next one, 2 plus 14 is 16 again, and so on. So each pair adds up to 16. And then there's 15 of these. For the 15 numbers that were in the original list, and divide by 2 because now we added the same whole thing twice, once forward and once in reverse. So this gives us 120. Alternatively, there's a formula for 1 plus 2 up to n. What is that formula?
N times n plus 1 over 2.
Good. Yep. So that's the same thing. You can either derive it kind of from writing it reverse and using this method, or if you just remember this formula, that also works, and you'll get the same thing. So 15 times 16 by 2. So it's a total of 120 days. So given that the first book finished on Sunday, you can think about it as it started on Sunday. So the one day after that was Monday. So then the total is 120 days. If I divide by 7, each becomes a week. So the remainder is 1, corresponding to 1 extra day. So it's the same as if it just took 1 day to read. So it should end on a Monday. Does this make sense? Any questions on this? And since we covered this formula of 1 plus 2 up to n, we've also done some similar formulas. Let's just review those. So we know this is 1 plus 2 up to n is n times n plus 1 over 2. What is the sum of squares? So 1 squared plus 2 squared up to n squared. Does anyone remember?
Is it n times 2n plus 1 over 6?
Close. There's one more term missing. Any guesses? So we can try this for 1 plus 2 plus 3 squared, 1 squared plus 2 squared plus 3 squared. What should it be?
Yep.
So let's try n times 2n plus 1 over 6 will give us what? So in this case, n would be 3. So 3 times 7 over 6. What is it missing?
Oh, it's 2n.
Yeah. Careful. In this case, so we can try one more and check, but.
N plus 1.
Good. Yeah. So in this case, n plus 1 and 2n are actually the same. Or actually, no, sorry, it would be 6 for that. Yeah, it's n plus 1. Good. And anyone remember what the cubes is? 1 cube plus 2 cube up to n cubed. So an easy way to remember it, it's just something related to this 1 plus 2 up to n and just some extra function on this sum.
Would it be n times n plus 1 and then 3n plus 1 instead of 2n over 6?
So that would be nice to remember if it was, but it's not. It's actually just this squared. So if you take 1 plus 2 plus 3 up to n, that gives you n times n plus 1 over 2. And if you just square that, you get the sum of cubes. It's a interesting property. So we can just, it's basically then n squared times n plus 1 squared over 4. Or you can think about it as n times n plus 1 over 2 and squaring this. Okay, so these are good formulas to remember when you need to add up sequences like this. And in this case, the 1 plus 2 up to n sequence is what you need to add up to get 120 here. Any questions? Okay, let's move on to the next question. Okay, 14 is correct. Pavan, can you explain?
Okay, so the question is asking the number that is the square of a positive integer n. So first, we can take the square root of the whole thing, which would be 5 to the 64th times 8 to the 25th.
Mhm.
And then we can simplify that even more because 8 is equal to 2 cubed. So there's a property where we can make it 2 to the 75 because we bring the 3 up, so we do 3 times 25. So it becomes 5 times 65 to the 64 times 2 to the 75. And then we can realize that if we multiply 5 times 2, it equals 10. And since a 10 has a 0 at the end, we don't really care about it because we're asking for the sum. So we try to see that we can do 10 to the 64 times 2 to the 11th because we subtract 64 from 75. And then 2 to the 11th is 2048. And you just add up the digits of that because everything else is a 0.
Good, yeah. So yeah, let's go over this. So basically you're told this number is the square of a positive integer n. So the first thing you want to do is take the square root of this. So this is some useful properties when you have something to the power something. So if I tell you 3 to the 10, the square root of that is just 3 to the 5. So I can do 1/2 of the exponent. In this case, since I'm multiplying two things, I can do that for both of them. So this is the same thing as either taking this half of the exponent, or I could square root the base. Both will give me the correct square root. But in this case, actually, what might be easier to start off is you can write everything. So 25 to the power 64, with exponent rules, 25 is 5 squared, right? So 5 squared to the power 64, we can write this as 5 to the power 128. And then 64 to the 25, as Pavan said, 64 is 2 to the power 6 to the power 25. So this is 2 to the power 150. So we can make things simpler by putting it in 5s and 2s, because the nice property is when I have a 5 and 2 together, I can just make it a 10. That just puts a 0 at the end of the number, and I don't have to worry about it in terms of the sum of the digits. So then what I'm trying to multiply now is 5 to the 128 times 2 to the 150th power, and the square root of that. So that would just be 5 to the half of 128 is 64 times 2 to the 150 divided by 2 is 75 is the number is n. Now what we want to know is the digit sum of this. So, but the nice property here is every 5 and 2 that's there, I can just pair it and say it says 0 at the end. It doesn't affect the digit sum. So from that, we can see 2 to the power 11 will be what is left, and we can take 64 zeros out. So 10 to the power 64. So this basically becomes 2 to the power 11, which is 2048, followed by 64 zeros. And the good thing is the zeros won't affect our digit sum. So all we care about is the 2048. So the digit sum there is just 2 plus 4 plus 8, which gives us 14. So there's a few things here that are good to know or remember. One is the exponent rules. So if I can write 25 as 5 squared, then 5 squared to the power 64, I multiply these exponents. So that becomes 5 to the 128. Same for the 64 to the 25. When you take the square root, you can just half this exponent when it's something to the power another exponent. So it's like another exponent of 0.5 is the square root. And then when you have 2s and 5s, and you can pair them off, that just gives you a 0 at the end, right? It's a factor of 10. So that's what makes it easier to actually compute the digit sum in this case of 2 plus 4 plus 8. Any questions on this? Okay, let's move on to the last question. Okay, I see one answer of 6 or more sequences. Are there any other answers? Okay, so 6 is close to the answer, but it is a little bit more. So Sanvi, why don't you explain how you got 6, and then we can see what extra might need to be counted.
So what I did was, you can have a sequence of 2, 3, 4, and so on numbers. So I started with 2 numbers. So these 2 numbers, if you want them to be consecutive, it'll be x plus x comma x plus 1. So it's 2x plus 1 should equal 345. And so 2x is equal to 344. You drop the 1 to the other side, and x will equal 172. So it should be 172, 173. And so I continue this. And then if we do 3 numbers, it would have to be 114, 115, 116. So you use the same method, and for 4 numbers. And so I went on, I did 2 numbers, 3 numbers, 4 numbers, 5 numbers. And then I got 2 more for a total of, so basically what I did was, for each number, it's kind of like adding 1 plus 2 plus 3 plus 4 based on how many numbers you have. So like for the sequence 172 to 173, it was 1. For 3 numbers, it would be 3. For 4 numbers, it would be 10. For 5 numbers, it would be, so for 5 numbers, it would be 10. And so then I got 6. But I didn't get to check all of them because I'm not really sure where it ended. So I kind of stopped there.
Makes sense. Okay, good. Yeah, so let's just fill in these. What was the sequence with 4 numbers?
The sequence with 4 numbers. There was no sequence with 4 numbers that
And which were the other ones that you got?
well, I found a 6 number one, 55, 56, 57, 58, 59, 60.
Okay.
The 2 other ones that I found, I didn't write them down because one of them was 14 numbers, I think, and the other one was 9 numbers.
And how many? I think it should have been 15, maybe. I'm not. 14 might also. Let's check.
I think it was 14 and 9. I'm not really sure of that.
Okay. Let's double check. Yeah. So yeah, this is good. So yeah, these are some of the sequences that you can get. Let's see if there's a way that we can kind of double check what could be all the possible sequences. And so one way of doing it, so I think this makes it a little bit trickier when you define. So like in this 2 case, we define this as x and x plus 1. And in like a 3, it would be x plus 1, x plus 2, and solve for x. What actually makes this a little bit easier is to always use the middle number to define things. And let's first just assume there's an odd number of elements in the sequence of consecutive numbers. So we'll go back to even in a minute. And let's first find all the possible odd number of consecutive numbers. So in that case, what would be, let's say the middle number is x. So then if there's 3 numbers, it would be x minus 1, x plus 1. If there was 5 numbers, it would be x minus 2, x minus 1, x plus 1, x plus 2, and so on. So in this case, what is the total sum of these numbers?
Five x.
Good. In this case, yep, it's 5x. Or if I just say there's some m is the number of odd numbers, then so in this case, we're setting that to 5. It's m times x, where x is the middle number in the sequence. So in this case, I could say, so m times x, and what should this equal to then? $345, right? We know what the sum of the sequence is. So we basically are then looking for, okay, what are the possible m and x values that we can have here for 345? So m should be an odd number. So in this case, let's say m is 5, then x will be what?
69.
Good. And this matches the sequence that we have here, right? If 69, when we had 5 numbers, 69 was the middle one. So 68, 67 were the 2 ones smaller, 70, 71 were the ones larger. So now what we are asking is, okay, what are the possible values of m here? So what can we do to find the values of m? So we know.
Factorize 345.
Go ahead. Yep.
Factorize 345.
Good. Yep. So that's a good step we should do. And what is the prime factorization of 345?
5 times 69.
Good.
Oh wait, that 69 is 3 times 23.
Good.
And that's it.
Good. Yep. So it's 3 times 5 times 23. Okay. So now we have the prime factorization of 345. Now we want to know what are the odd numbers that m could be here. So m could be 1. That works, but that's just 1 times 345, which we don't really care about because we want 2 or more integers. So 1 is the first possible. What's next?
Five.
Could be 5. Good. Is there anything smaller than 5 that's possible?
3.
Good. 1, 3, 5. What else?
23.
23. Anything else? What about a product of 2 factors?
15.
Good. Anything else?
45. No.
Careful. It has to be a factor of 345, right?
Oh, I mean, 69.
Good.
115.
115. And so we've basically covered all the factors of 345 here, right? Except for 345 itself. Okay, so now let's go back and see how these would fit in as sequences of numbers. So we already have, so 1 doesn't work, right? Because we need 2 or more. The question asks us for 2 or more consecutive positive integers. So we could have 1 number, but that just doesn't, that doesn't give us something that works. Then we have 3. So 3 numbers, 114, 115, 116, we already found that. 5 numbers, we already found that, 67, 68, 69, 70, 71. What's the next one? 15 numbers. Okay, so if we take m as 15, what would x be then?
Two.
23.
23, good. And the reason why is we needed to multiply to 345, right? So if we have 15, we know the remaining portion is 23. Okay, so 23 is the middle number. So what is the sequence here? What is the smallest and largest?
— 16 is the smallest.
Mm-hmm. Good. What's the largest?
30 is the largest.
Good. And we can confirm that this works. If you want, you can add it up and check. But a good way of seeing, okay, so 23, and there's 15 numbers here between 16 and 30. So this actually will add up to 345. So 15 numbers is possible. And now let's see, let's take the next one. So 23 numbers, let's try that out. So what's the middle number here?
— 15.
Good. So what's the smallest and largest?
Smallest is 4,
Good.
and the largest is 26.
Good. And again, you can confirm and add this up and check. But going from 4 to 26 will give you 23 numbers. So 26 minus 4 plus 1 is 23. Times 15 gives you 345. So good. So 15 and 23 are possible. Now, could we actually have 69 numbers? So let's take the next one and see. So what would be the middle number in that case?
Five.
5. So what would be the smallest and largest?
The smallest would be negative, but that's not possible.
Good. Yep. So it's actually something like negative 29. Yeah. And then 39. So this would actually give you 69 numbers. And they do add up to 345, but the key point was the question says consecutive positive integers. So because of that, we can't actually include this one. And the same thing would apply to if I took 115 numbers, the middle would be 3. That would also span negative and positive numbers. So we have to stop there and eliminate this. Okay, so now have we covered everything, or do we still need to check anything else? So we made one assumption right here. We assumed an odd number of consecutive numbers, right? So we did cover 3, 5, 15, 23, but we don't know if we've covered all the even number of consecutive integers. So we had found 2 and 6 before, but there could be more. So now we know we've covered all the odd numbers. Let's double check in the even case. That's a little bit messier because we can't necessarily express this as x plus 1, x minus 1, and this canceling. It's a little bit trickier, but let's see what that would look like with now changing this to an even number of consecutive numbers. So let's change this here to an even number. So that's, imagine if we have two numbers and we want to express this still in terms of the middle number. So if I have two numbers, it can be like x minus 0.5 and x plus 0.5. So what this means is it has to end, essentially this middle number has to end in 0.5, or essentially be an odd number divided by 2. And then I can write this as x minus 0.5, x plus 0.5. And then what would the sequence be if it had 4 numbers in it instead? So it would be something like x minus 1.5, x minus 0.5, x plus 0.5, and x plus 1.5. Okay, so now let's think about what the sum would be. So m is now an even number for the number of numbers. X is the middle number. So again, m times x is 345. But now the tricky piece is that this middle number is now not necessarily an integer, or shouldn't be an integer, it should end in 0.5. So now let's actually say that x is equal to some a divided by 2. Now we know that a has to be an integer, and it has to be actually an odd integer. So let's substitute that in here. And if we actually multiply both sides by 2 here, we get m times a is equal to 345 times 2. So now let's see what are the possible values of m that could work here. So we now know that both m and a have to be, so in this case, both m and a have to be integers. A has to be an odd number. M is the number, and m has to be an even number corresponding to the number of numbers in my sequence. And now let's look for the possible values of m, compute a, and now we know the middle number will be a over 2. So then we can take a over 2 plus 0.5 is the one above that, a over 2 minus 0.5 is the one below. So now what are the possible values of m here? Let me remove this. Any ideas? So what is the smallest possible value of m?
2,
Good. What is the next smallest value?
6,
Good. Next.
10,
Good.
and
Next.
then 30.
Good. Next.
46.
Good. Okay, I think that's good for now. We'll come back if we need any more. So 2 we've already gotten, 6 we've already gotten. So now let's check the next one, 10 numbers. So what is a here if m is 10? So we would have m is equal to 10, or sorry, m is equal to 10. What is a? So we know m times a is 345 times 2. Anyone?
69.
Yep, so m is equal to 10, a is equal to 69. So what is the middle numbers in the sequence? So the middle number will be a divided by 2. What is that?
$34.5.
Good. So 34, 35 will be the two middle numbers. So what is the full sequence then?
For the right side, 34, 35, 36, 37.
So we know there's a total of 10 numbers, right? So 34, 33, 32, that should have 5 numbers. 35, 36, 37, that should have 5 numbers. So we can fill that in. 33, 32, 31, 30. So now we have 5 numbers, 31 to 34 and 35 to 39. And you can sum this and double check. If you add up 30 to 39, you'll get 345. Okay, good. So now let's try the next one. So m is equal to 30. What would a be? So just compare this with this. We're multiplying m by 3, so what should happen to a?
A is equal to 23.
Good, 23. So what is the middle number?
12 and 13. I mean, no.
Yeah. Careful, 11 and 12. All right, 23 divided by 2 should be 11.5. So 11 and 12. So now what this means is that we have 30 numbers, right? So if the middle is 11.5, what is the smallest number?
-4?
Close, -3. So -3, -2, -1 up to 11 is the bottom half, and then 12 up to 26 should be the top half. So again, this violates the property, right? Because we need only positive integers. So once you have 30 numbers, you still have consecutive numbers that add up to 345, but they're not all positive. So we can get rid of this. 30 numbers doesn't work. So what should our answer be? So we've covered all the odd ones, we've covered all the even ones. And if we pick any number larger, again, 46, we'll see the same thing happens. We'll have to go through negative numbers to be able to reach a sum of 345. So what should the answer be here? So we found the sequences can be 2 numbers, 3 numbers, 5, 6, 10, 15, or 23 numbers, right?
7.
Good, 7. Yep. So there was just one more essentially missing. And then we found it this way by first looking at, so taking it in terms of the middle number makes it easier because things cancel on both sides, and we can just say the product of 2 numbers becomes 345. When it's an odd number, it's easier. We just looked for odd factors of 345. For an even number, we had to add this extra factor of 2 and then look for factors of this to find the possible values of m. And then we just had to double check to look for the sequence to make sure that they still had positive numbers. If it didn't matter, we could have just counted the number of factors here and taken that as the total number. Because we had to double check when it's positive integers, we looked at the sequence. You essentially have to make sure that the smallest number in the sequence is still above 0, and that works. And we double checked that for both the odd and even numbers and found that there were a total of 7 possible sequences here. Does this make sense?
Yes.
Any questions? Okay, then that's it for today's class. We'll see you all next week.
Happy teacher.
Thank you.
Bye.
Thank you.
Bye.
Bye, thank you.
You're welcome.